Welcome to the third and final part of our Python for Lego Spike Prime series. If you want to learn the tools and techniques to program your robot at a competitive level, then make sure you stick around. Hello, I'm Mr. Code, and today we're going to learn more Python for Spike Prime. And this video assumes that you have done the lessons and all the activities in parts 1 and 2. So if you haven't, then pause this video and watch my previous tutorials over here. You need a really solid grasp of all the basics before going any further. The sponsor of today's video is More Educational, who have kindly provided me with the LEGO Education Spike Prime kit today. More on them later in this video. The goal of today's lesson is to solve the most common challenges to making an efficient Python program for your robot. We're going to learn about writing functions. We're going to do multiple things at the same time. We're also going to use the gyroscope, the internal gyroscope, to navigate accurately. And finally, we're going to do some tips and tricks to save you time on the FLL competition fields as well. So it's going to be a lot of fun. All right, so let's start by loading up our new Python project. We're just going to call this Python Part 3 Create. And first things first, we're going to define all of our bits and pieces. So we are using the same robot that we used last lesson. So here is driving base 2 with an extra color sensor, but this time the color sensor is pointing up. It's not pointing down towards the ground because we're going to use it to help us control our program. So that's what we are using today. Here we're going to have a look at our code. We're going to define our wheels. Well, actually, I'm going to connect my robot first. Here we are. All right, so let's get started. So we go wheels equals motor pair, and then we define it as C and D. We also have an arm, so the arm equals motor at E. And I know it's E because I know C and D are the motor, is the motor pair, and there's only one more motor sticking out at E. So there we go. Distance sensor is equals to distance sensor at F. Force sensor equals force sensor at A. And finally, color sensor equals to color sensor at B. All right, so here is all of our bits and pieces connected together. So the first thing we're going to learn about is writing functions. Okay, so a function is a way to write repeatable custom code. Okay, it's sort of like MyBlocks in Scratch. Okay, in MyBlocks, you will create a MyBlock where you will define the name, and also you will give it some parameters, some inputs, if you like. That's the same thing with functions. With functions, we're doing the exact same thing where we are creating a MyBlock, and also we're giving it some parameters, some arguments to feed into the function, and then it's going to perform our task based on those arguments that we give it. So here we're going to create a bit of code to make our robot dance. So let's say we want to make our robot move forward and backwards. We're going to call it a dance. Okay, so wheels dot move, and then we're going to have a look at our motor pairs, and then we look at our motor move function. We're going to make it move forward half a rotation. Rotations. Steering is 0. Speed is going to be 50. Okay, and then we want to make move backwards as well. So here going to move it -50. All right, so if I press the play button, the robot is going to move forward and backwards. That's our little dance. Okay, so here, let's have a look at our robot. Press play. Okay, so robot is moving and dancing. All right, but what if I want this dance to go for longer? Well, we can create a loop, right? Remember in the first lesson how we created a bit of a loop using for loops and while loops? Well, we can do the same thing, but instead of using a loop now, we're going to use a function. Okay, I'm going to create a function called dance. Okay, and then I'm also going to give it an argument, a parameter, where if I have a really big number, then it dances for longer, but if it's a really small number, then it dances for less. So let's have a look at that, how we do that. We define all of our stuff at the top, and then to follow our coding convention, we should put our functions next. Okay, so functions go in between where we define all of our objects and where the code is executed. So here we do our functions. So we go def, that's the keyword for defining a function, def, dance. And then we want to put in how many times we want to dance. So we're going to put in amount. Okay, and then colon at the end of that. So how does this work? Well, based on the number that we put in amount, we want the robot to move forwards and backwards, okay, that amount of times. Okay, so we go for I in range amount. Okay, so this is the for loop that we learned in the first lesson, but instead of putting in a number inside range, we're going to put in the amount, which is the amount that we plug in. So it's probably worth commenting here. So def is the keyword to define a function. Dance is the function name, okay? So here, for I in range amount, and then I'm going to put in our moving forwards and backwards code here. Okay, so make sure that everything is indented properly. And what this does is it creates a function where it's called dance. And then inside the dance parameter, we have to put in an amount. All right, and then that amount will tell it how many times to move forwards and backwards. And to use the function, it's super simple. All we have to do is just go dance, and then however many times I want it to dance. So say dance 3 times. Okay, so if I press the play button, once, twice, 3 times. Okay, so why would I use a function instead of simply writing a loop in my execution? Well, there's a few reasons for doing that. If I write a function, I can name the function whatever I want. I called it dance, right? But I can equally call it any other number of things, and that gives you some clarity when you're doing your code. For example, if I was doing a mission on the table where I was doing, for example, the windmill mission in FLL Superpowered this year, then I can create a function called windmill instead of doing a loop, making our robot move forward and backwards and not knowing what part of the code that is doing. Okay, so it helps us get some clarity on our code, and also it makes it so that it is easily repeatable. So we don't have to copy and paste our for loops all the time, and also we can use our functions instead, and it makes it much tighter. As you can see, when you look at our code here, all you're writing now is dance 3, and then it does all that movement. Okay, really, really cool. And there's a lot of ways that we can use these functions, and then later on we're going to go through how we can use this function creation method to create our gyro turn codes as well. Okay. Second thing we want to do is, let's comment this out, is to do things multiple things at the same time. Okay, so let's move our wheels and our arm at the same time. Okay, this is a big challenge. With Python, it is a procedural programming language. Okay, that means that if you imagine that this was a piece of paper that is fed into a robot, this is what Python is like. Okay, Python reads one line at a time from the top of your code down to the bottom of your code. Okay, and it does everything based on where that read head is at the moment. Okay, so it reads one line at a time. But if you want to do two things at the same time, it's a little bit tricky. Okay, if I wanted to move my wheels forward and move my arm at the same time, then it needs a little bit of sideways thinking. Okay, so let's say I want to move forward with my wheels. So I go wheels, don't move. But actually, if I have a look at my moded pairs and then go move, you'll see that there's a whole bunch of ways that I can move. Let's go wheels don't move for half a second. Okay, so we move for half a second, and then also we want to move our arm for half a second. So arm dot run for, and this is a single motor, so we have to look for our single motors. And then we got run for seconds. Here we go. So arm dot run for seconds. And then let's have a look at the arguments. So here we want to run for half a second at speed of, say, 20 or negative 20. Because we're closing the arm. So if I press play and have a look, you're going to see that it's going to move forward first before it moves the arm down. Okay, so let's check that out again. Okay, that was really, really quick. But if I press play again, you see that? It moves forward and then it moves the arm down, which is not what we want. We want it to move at the same time. Okay, and the reason why it is not working for us is because in the code, Python reads from top down, one line at a time. When it reaches line 23, it says to move half a second forward with the wheels. So the wheels will move forward for half a second before the Python read head goes to the next line. Okay, so we need to somehow make it so that it moves both of these at the same time. So this is how we do it. Instead of using the move command, we have a very handy command called start. Okay, so when we go wheels dot start, then what happens is that it tells the motor to just start moving, and we're not going to wait until it finishes before going to the next line. Okay, and same thing for arm. Okay, so the single motor arm dot start, and then for single motors, it's slightly different as well. So in our double motors, well, let's go to start first. So we need to put a speed in the argument. So we go -20, right? And then wheels.start is also a speed. So here, if I go into our motor pair, wheels.start, we have a steering and then speed. Okay, so here we go 0 steering and speed. Let's make it like 30, really slow. All right. So this will make it so that both things happen at almost the same time. You won't tell the difference because in Python, it goes through one line after another several thousand times a second, all right? But the only time it stops is if you use the move command or the run for seconds command, where you will where Python will actually wait on that line until it finishes before going to the next line. Well, here it's going to say start the motor for the wheels, and then straight away in the next split second, next thousandths of a second, go to start the arm at the same time. Okay. Now, when these both run one after another, you won't tell the difference. It will both just start at the same time to us. Okay. So all we have to do now is, because we want to move it for just half a second, we use a helper function called wait. Okay, so we go wait for seconds, wait for, seconds, 0.5, and then we stop both the motors. So wheels.stop, and then arm.stop. See? So now we are doing two things at the same time. We are moving the wheels and also the arm at the same time. And then we are delaying for half a second before we stop both of them. Okay? And using these wait, this wait helper function can help you control and delay when things start and stop. And that will help you do multiple things at the same time. So let's press play. Okay, you see that? So it moved forward and moved the arm at the same time. Okay, let's do it one more time. See that? So Python is slightly different to using block-based coding, because with block-based coding, you can have multiple events triggering at the same time. With Python, you can't do that. So that is why we have to use really smart usage of this these time blocks, and also by starting and stopping your motors at the right time in order for that to work. Now, before we go on to the gyro turn code, I just wanted to say that all the code you see in today's video and throughout my channel are created by myself. I don't copy anyone else's code, which is why this channel is the #1 recommendation if you search for Python Lego tutorials. I spend huge amounts of time researching so that you don't have to. So if I helped you out in any way, then please consider liking and subscribing to my channel, because your support lets me continue making videos just like these. Let's go into our gyro turn code. Now, if I wanted to turn for exact amounts, okay, let's delete that stuff. If I wanted to turn an exact amount, then I would use the inbuilt gyroscope, or the gyro sensor in the Spike Prime hub. So the first thing I do is I need to reset my yaw angle. So yaw is the direction where we are turning side to side. So here we're going to say hub.motion sensor reset yaw angle. Okay, so this is going to make it so that wherever I am right now, I'm going to set that to be my zero degree position. And then if I wanted to turn 90 degrees towards the right, then I'll go while hub.motion sensor.get yaw angle is less than 90. Then I will go and say wheels.start at 100, so that's turning towards the right, and 20, that's the speed. And then at the end of that, once I reach 90 degrees, then I'll stop. So wheels.stop. Okay, so let's test this out, see if our robot turns 90 degrees. Okay, so it's turning 90 degrees, but it's a real hassle because there's so much code, right? So if I look at here again, I'm doing like 1, 2, 3, 4 lines of code every time I want to turn. And if you're thinking about doing a first Lego League mission where you're doing multiple turns, then this becomes really, really bothersome. So instead of doing that, we're going to create a function called Gyro Turn. Okay, so up here, we're going to create another function, def gyro turn, and we want to have two parameters for this one. This first one is the steering direction, so steering, and the second one is the angle. Okay, so the amount of degrees that we want to spin for. Okay, so here we define our function, and then we cut and paste all the stuff from our gyro turn. So here we'll just go and paste that in. So now all we have to do when we want to turn is we go gyro turn and then set the steering angle, steering and the angle, sorry. So steering replaces our steering at the start parameter, and then angle replaces this 90 degrees. So now I can spin any number of degrees. But now we have a second problem, okay? So the other problem now is that if we're turning towards the left, we're going from 0 to a negative number, okay? If I want to spin towards the left, then the negative number is always going to be smaller than the angle that we're turning, okay? We can't have that because that way this function will only work if we're turning towards the right. Okay, so now in order to do that, we're going to use something called the absolute value. So absolute value changes a negative number into a positive number. So here we go ABS, that's the absolute value of your angle is less than the angle. Okay, so now if I want to do the gyro turn, let's try that. So gyro turn, I'll turn, say, towards the right 45 degrees. Test that out first. Good, so it's working. So now let's test it turning towards the left. So here, left, so negative 145 degrees. Okay, so that is how you can make your robot turn accurately using the inbuilt gyroscope. The next thing we're going to learn is how to save time running different programs. Now, if you have any experience with EV3 or Spike Prime when you're doing a competition, you'll notice that if you switch between different programs, it takes a lot of time. Okay, so the way we get around it is by creating something called a master program, where we use one program and then trigger different movements or different commands using some buttons on the screen, or using the color sensor to sense different colors and give it instructions that way. Okay, so we are going to learn how to use our color sensor, because we've flipped it up, to run different programs on your robot and make it so that you don't have to keep running different programs and stopping and starting your program. So this is how we do that. Okay, let's say I have multiple programs. Okay, so here we have, we'll just comment out the gyro turn. Using color sensor, whoops, American spelling, sensor to run different programs. Okay, and for us, we're going to make a very simple program. Okay, we're going to make it so that if I scan a yellow block on the color sensor, it's going to do a dance. If I scan a blue block on the color sensor, it's going to do a bigger dance. And then if I scan a red block on the color sensor, it'll do a gyro turn one direction. And then maybe a purple block, gyro turn another direction. Okay, so let's do that. So all we have to do is we say color sensor dot wait for color. Okay, wait for color. Okay, so when we go color sensor.wait for color, then what happens is, oh, sorry, not wait for color, wait until color. Wait until color, and then we'll say yellow. Double check if I need to make it capital or anything. Nope. Wait until color yellow, and then we're going to do a dance. So we go dance 2 times. Okay, so let's test it out. Okay, so our robot's just happily standing there, and then if I scan a yellow block on it, it's going to do a little dance, and it doesn't work if I scan any other color. And I want to make it so that if I scan the red block, it's going to do a gyro turn. So let's go back over here. So color sensor wait until color red gyro turn 100 for 30 degrees. Okay, let's run that. All right, so I scan red color. It's not working. All right, and it's not working because of what we talked about earlier in the lesson. Okay, earlier in the lesson we said that Python reads through one line at a time. Okay, and then it waits if on the line if it needs to wait for something to finish. So here, Python is stuck on line 41, where it's waiting for the color to turn yellow first. Okay, and then it's going to do a dance before it starts to wait for the color to be red. So if I scanned yellow first, then it will work. But if I try to scan red first, it doesn't. Okay, so here, if I scan red, it's not doing anything. All right, it has to scan yellow first. Okay, and then if I scan red, it's going to work. All right, so that's bothersome. We don't want that to happen. We want to make it so that we can scan these colors in any order we want. Yeah. For some programs, you might want to just make it so that it scans one color at a time. For example, if you're scanning the same color, you want to make it do one at a time, right? But let's say I was in a match and I want to be able to choose which program I run. Okay, so instead of using wait until color, we're going to do something else called wait for new color. Okay, so here we'll say while true. Okay, and what does while true do? If you remember from our first lesson, while true makes us repeat something forever. Okay, and what are we waiting forever? We're waiting for wait for new color. Okay, and what wait for new color does is that it simply only triggers when a new color appears in front of the color sensor. Okay, so wait for new color. Now, instead of wait for new color and then checking for each color like this, because this will only wait for that exact color. We don't know what color is going to happen. So instead of that, we're going to use something called get color. So here, we're going to go get color. If get color is equal to yellow, then we're going to dance. Okay? Elif stands for else if. Get color is red. Then we do the gyro turn. 130. Okay? So this makes it so that it's going to go in a loop where we're constantly waiting for the new color to come up. So if I run that, whoop, there is now an error. Let's have a look at what this error is. Unexpected indent. Let's have a look. Where did I indent? Wait to get new color. Wait for new. Ah, yes. That's not supposed to be indented. There we go. Nope. Still got an error. Let's have a look. If get color. What is this? Wait for new color isn't defined. Of course not. It's color sensor. Dot wait for new color. There we go. Oh, still got an error. What is this? Get color isn't defined. Yeah, it's because I have to keep saying color sensor dot get new color. Get color. All right. Finally. What did I do? 9:45. Okay. Please don't give me any more errors. Finally. Okay, so here, now I can scan the red block or the yellow block at any time. Right? So, and this is really fun because this means that you can get your robot to do all sorts of stuff, all different commands at any time throughout your competition so that you don't have to keep flicking through the programs and waste a whole stack of time. So here, in order to create more programs, we can just do another elif, right? So here you go, elif, color is blue. We're going to do another dance, 3. And here I'm going to do another elif, violet. You're going to gyro turn the opposite direction. Okay? Is it running? Yeah. All right. Violet, red, yellow, and blue. I want to thank the sponsor of today's video, More Educational. Ever since Creator Academy started making LEGO education videos, we have been greatly supported by the experts at More Educational. They are an authorized partner of LEGO Education with over 20 years experience working with LEGO education products. So if you're in Australia and you want to buy genuine LEGO education products like the ones shown in this video, then make sure you check out the More Educational website. That's it from us today, and although this is the end of our introduction to Python for LEGO Spike Prime, there are more videos on the way because a new version of LEGO Spike has just been released. I cannot wait to try version 3, and I will see you next time. Take care, everyone. Bye-bye.